Good afternoon and welcome to the 21st annual exhibit of hydrogen and fuel cell technologies. We've added batteries to the mix, and that's very apropos because we'll be talking about storage facilities, sodium batteries. It sounds like a big innovation. We'll be talking to Dr. Matthias Schulz, who's scientist at Fraunhofer-Institut für Keramische Technologien, also ceramic technologies, and we'll be talking about the status and prospects of cerenergy sodium batteries.
Thanks a lot for your introduction. Ladies and gentlemen, good afternoon and welcome to my presentation today here at the Hannover Fair. My name is Matthias Schulz. I'm scientist and leader of the work group Stationary Energy Storage at the Fraunhofer-Institut for Ceramic Technologies and Systems, and I come from Hermsdorf. This is located in the beautiful Thuringia. Okay, the title of my talk is Status and Prospects of Cerenergy, Ceramic High Temperature Batteries. First of all, let me give you the agenda of my talk. In the first few slides, I will represent you some figures, some facts, some dates about my institute. In the second part of the talk, I come to the core of my talk, the cerenergy technology platform. So what is cerenergy? What is the cerenergy technology platform? What are the prospects of cerenergy technologies? And what is the current status of research and development at my institute at the moment? At last, a short summary and an outlook, of course. So my institute, of course, it belongs to the big Fraunhofer Association. The Fraunhofer IKTS is one of about 60 Fraunhofer institutes in Germany. We are one of the biggest. We have 3 facilities. The headquarters is located in Dresden in the Winterbergstraße at the Fraunhofer campus. Another facility is located in Thuringia in Hermsdorf. That's where I come from. And since 2014, we have a third facility. This is located in Dresden-Klotzsche too. Beside these main facilities, we have a number of application centers. These application centers are a kind of pilot production, very close related to demands that we receive from industry. We have a battery technology pilot plant and application center. Together with ThyssenKrupp System Engineerings, we develop technologies for the manufacturing of lithium-ion batteries there. Another application center is related to research with bioenergy. This is in Pöhl in Saxony, and a third application center is doing research in ceramic membrane technology. This is in Schmalkalden in Thuringia. For a couple of years now, we have a phalanx in the United States. We have the Center for Energy and Innovation in Connecticut in the USA. At this transparency, some figures about my institute, some dates, some facts, yes. As I already mentioned, we are one of the biggest Fraunhofer institutes in the Fraunhofer organization. These numbers are from 2015. In 2015, we had about 580 full-time equivalents. With other words, we are about 700 employees in my institute. We had an operating budget of 50 million euros, and we had industrial revenues of about 19 million euros in 2015. These 90 million euros underline significantly that we are doing research closely related to demands from industry. Okay, my big boss is the institute director, this Professor Dr. Alexander Michaelis. So now let me tell you something about cerenergy. What is cerenergy? What is the cerenergy technology platform? Cerenergy is a technology platform for sodium-based energy storage and conversion. In 2010 or 2011, we realized that there are customers coming to us and asking for battery technologies, for research activities related to battery research and development activities. There was, the renewables were growing, and we realized, okay, there's research activity, there's an upcoming research activity, and there will be a market for batteries. So what have we done? We did a screening of all technologies, of all battery technologies that were on the market at that time and that were under development. And then we had a look at ourselves. okay, we try to find out what key competencies do we have at Fraunhofer IKTS to build up, to do research, to develop batteries. So we are a material science institute that is doing science related to ceramic materials, and we know how to manufacture, to develop electrolyte, ceramic electrolyte materials. We know how to build up to cells and modules, how to design them. We learned a lot from our SOC activities in the last decades. We know how to do electrochemistry, in particular high temperature electrochemistry. And of course we can do modeling of material behavior, of component behavior, of systems. And last but not least, we can realize a system integration. That means on the value chain from the material, from the raw material to the working and ready to market system, we are able to, to develop ceramic-based energy storage technologies. So we decided to go into the development activities related to sodium-based energy storage and conversion technologies. So what applications do we address with the cerenergy technology platform? The core of cerenergy and the key elements of all the applications that are listed here is the ceramic solid electrolyte. This is a sodium ion conductive ceramic, and all these applications have in common that they use these ceramics that you can see here in the center of the transparency, that you need these ceramics to build a battery or a energy conversion, an Amtech alkali metal thermoelectric converters. Okay, on the left side of the transparency you can see the high temperature applications. First of all, we are developing sodium nickel chloride batteries. This is the main focus of our actual research that we are doing at IKTS. We can develop sodium sulfur batteries. Another idea is sodium flow batteries, or we can do development in Amtech alkali metal thermoelectric converters for high temperature energy harvesting. On the right side of the transparency, there are listed some low temperature applications of the cerenergy platform: solid state sodium batteries, medium and low temperature sodium batteries. All these technologies belong to the cerenergy technology platform, but at the moment we are focused on sodium nickel chloride batteries, and in the next transparencies and in the next few minutes I will tell you a little bit more about this technology. Okay, we have all these beautiful technologies based on high temperature sodium, and we have upcoming business cases for batteries. In this diagram that was published at the beginning of this year from a few colleagues of mine, you can see a forecast of and the experts are thinking about an annual growth rate of about 30% in the next few years for battery storage applications. We have a number of very interesting applications of business cases that we detected. Of course, on the left hand we have customer-focused business cases. First of all, the self-consumption. Everybody who has a PV panel on top of this roof wants to consume its own electrons in-house. This is a very common idea, in particular in Germany. We have demand charge reduction, we have backup power application, off-grid power application, and we can do electricity price arbitrage with batteries. On the right hand, we have grid service business cases that you can do with batteries. We all know that the renewables are a nice technology, but they make problems in our grid. We need to stabilize our grid, and we need to integrate the renewables into our existing grids, and therefore we need batteries. We can do off-site renewable generation peak shifting, and we can realize primary and secondary control reserve with batteries. So we have fancy technologies, we have good technologies in the cerenergy technology platform. We have a list of business cases. We expect an impressive growth of business with batteries, but there's a showstopper. At the moment, nobody can really do business with batteries, in particular for stationary applications. This is due to the costs, of course. Business will start at costs below $150 per kilowatt hours for e-mobility applications, and we think that for stationary storage the costs need to be lower. This diagram here was published from Mr. Nyquist in 2015. This is quite actual. he collected some data for lithium-ion batteries, and you can see here where we are today. In 2015, we have prices on cell levels between 300 up to 600 euros, no, US dollars per kilowatt hour. And we need to bring down the costs on the level about 100, 150 US dollar per kilowatt hour on cell level. So there's no business today. The cerenergy technology, in particular the sodium nickel chloride batteries, can be a solution for this problem. The message is just use sodium instead of lithium and have a look at a well-proven, almost forgotten technology, because sodium nickel chloride batteries and sodium sulfur batteries are an old technology, but they are almost forgotten. And that's what we are doing at IKTS. We have some development objectives and technology advantages listed here. The first and the main goal of our development is bring down the costs. We are doing this in research projects at the moment via an optimized cell design and an improved manufacturing technology. We have good performance of the batteries. You can compare the energy density with lithium-ion batteries. Our batteries are a little bit slower. You can't use it for all applications, but in particular for stationary applications, this is an excellent technology. We are independent from restricted raw materials. There's no lithium inside, there are no raw materials inside the cerenergy batteries. And the sodium nickel chloride batteries are intrinsic safe. You will never have a thermal runaway with these battery cells. So we think that sodium nickel chloride batteries can reach target costs below 100 euro per kilowatt hours, and they are a very attractive alternative beside lithium. To reach these development objectives, we have some design rules. We think that low cost is much more important than high power density or energy density. You can compensate the energy density by a higher number of cells. If the cell is cheap enough, this doesn't matter. One cell should be sufficient for a wide range of applications. We believe in the economies of scale. Low-cost electrolyte design will define your cell design. The core component, as I already explained to you in a few slides before, of these cerenergy technologies and of the sodium nickel chloride batteries is a ceramic solid electrolyte. And to manufacture this solid electrolyte is, yes, the biggest challenge to develop a cheap battery. And we think if you manage to manufacture these solid electrolytes as easy as possible, the rest will be simple to do. We need quality tests for every single step in the manufacturing line. We do not rely on narrow tolerances. We need design robustness, and we think that we will definitely need an automatization of all manufacturing steps in the process line. Okay. What's the current status of cerenergy, and what's the status of our research and development activities at IKTS? Everything starts with the raw materials. In the last years, we did a really wide screening of raw materials on the market. For every shaping technology and for every application in the cerenergy technology platform, we identified good materials, abundant materials. Then we did development in technologies to manufacture intermediates. We did experiments with mixing grinding technologies with thermal treatments and granulation processes. The next step in the process line are intermediates. For different shaping technologies to manufacture the ceramic components, the ceramic solid electrolyte, you need different intermediates. It means we can manufacture powders, we can manufacture slurries, granules, depending on the shaping technology that I will show you in the next slide. Shaping, the next step in the ceramic process line is, the heart of the ceramic process line. The common technology, the technology that is used at the moment to manufacture solid electrolytes is the isostatic pressing technology. We use this technology at IKTS too, and we can manufacture these beautiful electrolyte tubes, as you can see in the center of the slide here. but we do not believe that the pressing technology will be a good technology to scale up the production. Isostatic pressing is too slow. We have cycle times of about 2 minutes to manufacture only one of those tubes. That's why our focus at the moment is on the plastic extrusion of the sodium beta alumina solid electrolytes. At the left side of the transparency, you can see a picture of this plastic extrusion process. This is a highly productive manufacturing, highly productive shaping technology. For flat cell designs, you can compare this with a stack design. We will start a big public-funded research project in September of this year. There we want to develop tape casting technology for flat solid electrolytes. Beside the sodium ion conductive ceramics, we need, of course, other ingredients to build up a working cell. For the sodium nickel chloride batteries, we need to develop, or we are on the way to develop, the cathode material. This is a mixture of salt and nickel powder, and in-house we have all the technologies to do this. At the left side you can see an example picture of the mixing and compacting machine that we have. We can form granules in different shapes and different densities. And from time to time, it depends on the application, we can do a post-treatment, for instance, a thermal treatment, as you can see it in the picture on the right side of this transparency. For testing of our ceramic components, of the solid electrolytes and of the cathode materials, we need high temperature electrochemistry and we need cells. Therefore, we developed a few different designs for lab scale experiments, and a design for commercial cell is under development at the moment. At the left side you can see a planar test cell. The white disc that you see there is a small solid electrolyte with a diameter of 20 millimeters, and this cell has a capacity between 200 up to 500 milliampere hours. We do cathode testings in this small flat cell design. In the middle of the transparency, you can see our working horse. This is a tubular test cell with a capacity of 10 ampere hours, and all electrochemical tests that we are doing at the moment, almost all, cell cycling and so on, were realized in these test cells. On the right hand of the transparency, there's a thinkable design of a 40 ampere hour sodium nickel chloride cell. And we have running projects at the moment with partners from industry to bring these cells to market, and it will take maybe 1.5 years to do this. Okay, last slide of my talk. Let me summarize the talk a little bit. There's no business for batteries in the stationary application field at the moment due to the costs. We have fancy, excellent technologies in the cerenergy technology platform, in particular the sodium nickel chloride batteries, that with this technology we will reach costs on cell level below 100 euro per kilowatt hours. IKTS is a big ceramic institute that provides engineering and research services to bring these technologies, all these cerenergy technologies, to market. We are open for cooperation with industry. And my last statement for this talk is, there is a competitive technology beside lithium. We will need lithium. Lithium is an attractive technology for many applications, but to solve the huge upcoming problems in our grid, we will need other technologies, and cerenergy is one thinkable solution. Thank you very much for your attention.
Thank you. Do we have any questions from the audience? I have 2 quick points. Just briefly, you mentioned environmentally safe.
Yes.
Okay. Is there a premium on safe battery technology? Because there should be, of course. Lead batteries are often thrown away. There's environmental costs there. Is there any European legislation that gives you an extra sales advantage?
No.
No. Okay.
Yeah.
So
No.
we'll work on that.
Yes.
Question 1. Question 2, you said that low cost is better than high energy density. So basically you are already interested not primarily in the mobile market,
No.
but in the stationary.
We do not address the mobile market. We only look at the stationary energy storage
Okay, so
applications.
whenever we say stationary, you're looking at larger scale storage.
Not only for home use, for instance, you need system sizes between 5, maybe 10 kilowatt hours. We
Okay.
address this market, of course, too. But we think about big systems too, yes, of course, in the megawatt hour range.
Okay, so that is an interesting large market.
Yes.
Because renewables are, not being used because they're not being stored.
Yeah.
Okay, thank you very much. We'll be continuing our conversation here in a few minutes. I've been talking to Dr. Matthias Schulz, scientist at Fraunhofer-Institut. Visit him at the booth B40 and continue the conversation there. It's been a pleasure. Thank you very much.
Thank you.